I'm doing things a little bit out of order so I can get to that meeting, which kind of nice to have Bill on a Friday anyway, so just kind of skipping around just a little bit today. All right, so a force is anything that's a push or a pull, all right? And so that could be like a horizontal push or pull, can be a horizontal or it can be a vertical, right? It can be pretty much any direction, but you're talking about some kind of push, some kind of pull. And again, I said that this is a pretty common, easy to understand unit for the most part, because all these forces are all around us all the time, and so we're used to that. So obviously this guy is pushing on this rock. Do you think that he's going to be able to get that rock to move? I mean, let's say this is a real person, not a statue person. Do you think he can move that rock? Gut instinct is probably no. He's still exerting a force though. And so even if you aren't getting something to move, you can still be applying a force. You just can't overcome the force that's keeping this rock in contact with the ground. Obviously, probably that baby is able to move the ball, we would imagine. Hard to tell whether this tug or this pull, this tension force is able to pull the plane where they have, all those probably Air Force men and women trying to pull it. Probably could get it rolling because it's on wheels, maybe. And then this looks like kind of like a strongman contest where they hook the guys up to all kinds of crazy things and see if they can get them moving. Again, if you can overcome the resting inertia of that big heavy item, whether it looks like the Humvee or whether it's the plane, if you can get that overcome, then you can get that object in motion. But still, they're applying force whether or not they're getting those objects to move. Force is a vector. So vector has direction, right? We know that now because of last unit with our Vectin villain who committed his crimes with both direction and magnitude. We're going to use arrows typically to show motion. And this is something we talked about a lot last year. You remember that. So just like velocity and acceleration, forces are going to have magnitude and direction. Okay, so again, a force is a push or a pull. Sometimes we'll say a tension force is like a hanging force. Or a tension force can also be a pull. So we'll call these forces, these pushes and pulls, by different names, or kind of get a little bit more specific with them. But again, it's a pretty easy idea. Here's some common ones: friction, drag, gravity, lift. And we'll get into all those a little bit more, obviously. So here we see they are doing a pull up. They are pulling themselves up. She is doing a plank, pushing herself off of the ground. Ooh, right? That's a definite push. Popping the old helmet off. He looks like he's maybe going to go through some concussion protocol. I don't know. His eyes look a little bit funny there. So just obviously some very basic examples. Again, forces are all around us. So this is a pretty basic, easy idea to understand. So we're going to measure force with something called the Newton. A Newton is really a kilogram times a meter per second squared. Well, a kilogram is mass, and the meter per second squared we know is acceleration. So really, the Newton is a mass times an acceleration. And that's going to kind of lead us into our next formula that we'll use. Okay. A force can be measured with something called a spring scale. It might be, I'll show you one tomorrow, but if you've ever done the grocery shopping and you go to the produce department, sometimes they have like a little scale and you can like hang the bananas, or they have like a bowl and it has a chain and then it's hooked to a scale. Those are considered spring scales. It's using the force of gravity and it converts that into that weight that you can then determine like how many grapes are you getting, or like how many pounds of bananas or whatever it might be. If you do any fishing, sometimes you use spring scales to measure the weight of those fish, right? So those might be some common things that you might be used to. So if you look at this punter or kicker, what forces do you think are being exerted on that football? What do you think? Cole?
Gravity.
Okay, gravity's always at work, right? It's pulling down, right? So that's one. As it was touching his toe, what's another force do you think that was applied to that football? What do you think?
Push.
Yeah, there's a push of some sort, right? So the force applied and then the pull of gravity. And so if you remember from last year, we could diagram out the forces that were at work on something by a little diagram. We call that a force diagram. So we're going to kind of get into that a little bit more. Let's go ahead and we will stop there. I said it was short.